So now we're on to the second half of the IB test. Remember, these are supposed to be done on a separate piece of paper, like a book that they give you. Right, so these they don't want you writing solutions on here. They want you writing a separate piece of paper. Now, for the sake of space, I'm writing mostly on here, and I'll try to, when I need space, I'll move down. But for the most part, I'm gonna write them on here. On the IB test, do not do that. So first, this is a vector question. Oh, I love me some vector questions. So first, they want me to show that AB equals this. So remember, when they do this, this is B minus A. And this is also a direction vector. So B minus A would be, I like to write it vertically, minus 2, 1, 4. You just subtract across, so I get -1, 0, and 1. Now remember, when they give you show that, you do not use it on that problem. You use it later on, but you don't use it on that problem. You got to get that independently. You can't just use that value. Now the reason they give you show that is because if you can't figure out how to do that, you can still use that problem for the next problems, not for this one. So that's A, done easily. And now hence, write down a vector. So remember, let me go back to this. The line L1 passes through A and B. So they're saying you have some line over here called L1 that has the point A on it and the point B on it. Hence, write down the direction vector of L1. So that's literally just the thing we just found. When you have two vectors like that, that's a direction vector. So my direction vector here is -1, 0, 1. Done. 2, write a vector equation L1. So this is a question they love to ask. So a vector equation in your former sheet is this. That's a vector equation in your former sheet. A is always the initial point, or the starting point. And then B is your direction vector. So B is never just like B or A. It's a direction vector. You need two vectors. You need A, B to be there. So in this case, we're going to use AB. So my direction vector is going to be, let me rewrite this. It's going to be R equals, since I'm doing AB, my initial point is A. So A is 2, 1, 4 plus my T, like my time, my direction vector, which is the AB I just found, -1, 0, 1. And there it is. And there's L1. Now this part, another line L2 has an equation, R equals 4, 7, -4 plus S, 0, -1. The lines L1 and L2 intersect at point P. Intersect. Remember, when two things intersect, you set them equal to each other. Set equal to each other. That's how you find stuff when they intersect. You set them equal to each other. And it's no different with vectors. So here, find the coordinates of P. So I'm gonna set them equal to each other. I'm gonna find a variable, either S or T, doesn't matter which one, and then you plug it back into its vector to find coordinates of P. You want to figure out where they intersect. So I'm gonna write that down here. Let's write my L1 first, which is 2, 1, 4 plus T times -1, 0, 1 equals L2, which they give me right there, 4, 7, -4 plus S, 0, -1, 1. Now remember, the way you solve is you split them up. So you do like the top layer equals this, and then you could do all the layers if you want, times 0. I'm gonna do the top two because mostly you just need two of them. And in this case, we're actually lucky. If you notice here, 0 times S is just gonna be 0. So if I solve the top one, I'm just gonna get this: 2 plus -T equals 4. So I can solve this for T pretty easily. -T equals 2, T equals -2. Now keep in mind, all they want to do is to find coordinates of P. So I do not got to solve for S. You go ahead if you want, but you don't need to solve for it. Once I have my T equals -2, I just got to plug it back into the equation with T in it. So plug it back into this equation to find my coordinates. That's it, right? It doesn't say solve for T and S, it says solve for P. So once you get your T, plug it back in. So my P, coordinate P is going to be this: 2, 1, 4 plus -2, -1, 0, 1. Right? I'm just plugging it back into the equation with the P in it, the T in it. That -2 gets multiplied by all of them, so it becomes 2, 1, 4 plus 2, 0, -2. So I get 4, 1, 2, and that's the coordinates of P. So now let's go back to D. Write down the direction vector of L2. They're just trying to give you points here. Here's L2. The direction vector is this guy, right? Just like what we did with ours. So direction vector of L2, it's just 0, -1, and 1. That's it. That's the direction vector of L2. 3 points. Next, hence find the angle between L1 and L2. So this one we'll do on the side piece of paper because I'm out of space. So 2. They want you to find the angle between two vectors. So that's this formula. It's in your formula sheet. Cosine theta equals A dot B over the magnitude of A, the magnitude of B. Now, key thing here is, what is my A and B? Right? You have these big old vector equations. Well, A and B are always the direction vectors. So my A here is going to be the direction vector of one of them. Let's say the first one, -1, 0, 1. Direction vector of L1. And then B would be the direction vector of the other one, of L2, which is 0, -1, 1. So that's my A and B. So the top parts, it's a dot product. So remember, dot product, all you do is multiply the corresponding parts and then add them up. So I'm doing a dot product. I'm going to get -1 times 0 is 0 plus 0 times -1 is 0 plus 1 times 1 is 1. So that's up there, 1. The bottom is the magnitude of each one. Now the way you do the magnitude is the formula sheet. Magnitude, you just get each component and square it, add them up, and take the square root. Alright, so magnitude formula, I should write it somewhere. It's this. A squared plus B squared plus C squared. So for A, I get square root of 1 plus 0 plus 1, which is square root of 2. For B, 0 squared plus -1 squared plus 1 squared. 0 plus 1 plus 1, again, square root of 2. So let's put all there, put it all together now. Cosine of theta equals 1 over rad 2 times rad 2. So cosine theta equals 1 over radical 4, also known as 1/2. Now remember, they wanted the angle. That's not done yet. I'm almost done. I get lots of points, but I'm not done yet. They want the angle between. So I got to go back to some more trig. Where does cosine equal 1/2? So however you do that works. I don't care how you do it. I'm a fan of a triangle, so I go all students take calculus. So cosine is positive here and here. I draw my little triangle. Cosine SOHCAHTOA, A over H. So this is 1 and this is 2 and this is radical 3. And that type of angle is a 60-degree angle. So 60 degrees, or pi over 3. And that's the answer to that one.